Thank you. My name is Tyler Moody. I'm a platform engineer at Sonic, and I work on the delivery infrastructure team. So our roles and responsibilities are centered entirely around CI/CD. We work heavily with GoCD and Gomatic, so I figured I'd come over here and give you guys an introduction to the tool. Disclaimer, I am not arguing that this tool is better than any other CI/CD tool out there. I do not want to enter into that philosophical debate. I just want to introduce you guys to this and show a basic setup. So, second disclaimer, GoCD is the actual CI/CD tool, and Gomatic is the piece that allows us to do pipelines as code. So, without further ado, some basics for GoCD before we dive into this. Your general infrastructure is you're going to have a single server that holds the configuration for all of your pipelines, and then you've got a series of agents, and those agents will poll the server for jobs, so basically poll for a pipeline execution and then go and execute whatever needs to happen. Then there's the whole series of GoCD objects. So basically, GoCD breaks it down into pipeline groups, so it's a logical grouping of pipelines. An actual pipeline, which is a single pipeline object that consists of a set of stages. Those stages are actually a set of jobs, and a set of jobs contain each a set of tasks. Tasks are run inline, so that's basically your individual commands that execute. Jobs can be run asynchronously, so those can be picked up by multiple agents. And then stages will have multiple jobs. So it's a lot that's going on, but I'll go through. We're actually going to eventually potentially do a live demo where I'll step through and explain each of those pieces again. I know a lot when I'm just talking about it. So the pipeline magic, how this is really supposed to work. So GoCD's end goal is to treat pipelines as a first-class citizen. It's all centered on the pipeline, the manipulation of the pipeline, and leveraging it. So one of the things that is really important with that is using Gomatic to configure, and you can do all of the same configurations on the GoCD UI through Gomatic. They use also a fan-in, fan-out methodology. So the concept is basically that you can have multiple pipelines running in sync that can then feed into a single pipeline, which also kind of goes along with this pipeline materials. So really to take a step back, a pipeline has a material. It can be source control, it can be a timer trigger, it can be or there's a series of things it can be. And one of the other things it could be is another pipeline. So you could run inline. An example of this, something we do at Sonic, is we have a pipeline that's responsible for actually building our API, and then another pipeline that is downstream that's responsible for deploying it out and making sure that it goes live properly. So this fan-in, fan-out methodology allows us to do a build and then a deployment to an environment, and at the same time run integration tests before fanning back in to potentially another deployment pipeline or another part of a build, et cetera. There's a value stream map that's provided by the GoCD UI. And basically what that is the whole mapping of your upstream, downstream pipelines, the source control you might be pulling from. So it gives you a really nice breakdown of how everything is connected together and the importance of that. GoCD also has secrets. So it has a secret encryption endpoint using a ciphertext. It does not have a decryption endpoint, which makes me really happy because that means you can't go to the server to find out what your secrets are. And basically at pipeline execution time, if a pipeline needs to get a hold of secrets, when the agent pulls, the server is responsible for decrypting those secrets and passing them off to the agent. So really the agent's only responsibility is to receive its orders and all of the environment variables or whatever else it might need, as well as the secrets, and carry out those orders. And then there's also another plugin, which I have a link to, and if we have time, I'll go to the GitHub repo, that allows you to do YAML configuration files as opposed to using Gomatic, which is a Python library. So pick your flavor, however you really want to do this. We lean heavily on Gomatic with the exception of a few different pipelines that might use YAML configuration. But it's really up to you guys how you want to go about this. All right, so the necessities for standing up a GoCD server. You need a source control SSH key. If you're going to be pulling from GitHub, Bitbucket, whatever, you need to have an SSH key configured so that the server can clone down whatever it is you want to use. Wherever you're running the server, port's got to be open on 8153 and 8154. The UI and the API are served through 8153, and agent connections are handled through 8154. As a note, and I'll probably repeat this later, agents need to connect directly to the box. I recently wasted like a week of my time trying to run agent connections through a load balancer, and the server will actually slap them away, assuming a man-in-the-middle attack. There is a way to set up reverse proxying. I've never done it, but it is on the GoCD docs. So as a rule of thumb, I just have them connect directly because it's significantly easier. Needs to have Java installed. A lot of people, when they see GoCD, they assume it's built out of Golang. It's not. It runs Java. So fun little fact there. And then a ciphertext file, which I didn't set up because I didn't do secrets for my demo. But you can generate your own ciphertext file and dump that onto the server, and that's what it will use to handle the encryption. Agent necessities, an auto register key. So the server has one main configuration file called the cruise config. So it's cruiseconfig.xml. And within that, that's generated when you install the server. And it also creates an auto register key. What you can do is you can take that, you can put it in the auto register.properties file on an agent and point the agent at that server, and it will reach out, and if it has that key, it will automatically connect. There's no additional work done for you. So you can automate the process entirely of standing up new ones because you don't have to go in and enable agents or anything like that. You can tear down and start back up. Some MVARs, it needs to know the Go server URL, so basically point me in the right direction so I know who to connect to. And a working dir default. And then whatever tools you want. So that's the other thing, is you kind of have to configure these agents with whatever you're going to do. And resource tags is the other piece. So the resource tags will actually go with the auto register key. And it's basically a way of logically separating agents. So if you want to break them down into very niche responsibilities, like one of them is responsible for building Java code, another one's responsible for building and publishing Docker images, another one's responsible for executing Terraform code or Ansible code. That's how you can do some logical grouping and have separate agents with separate responsibilities and not have them get really bloated and horrifying to work with. Gomatic, it's a Python library. You write Python code. It's built by ThoughtWorks. GoCD is also built by ThoughtWorks. It's maintained by them. And the releases are kept roughly in lockstep with the new version releases. I say roughly because they're a little behind, and sometimes they tend to because it's a voluntary maintenance on that. You usually have to reach out to ask. So I actually ran into an issue today prepping the live demo where I was setting up GoCD 18.12, and Gomatic only worked with 18.5. That was the latest version, so I had to revert back to 18.5 and make sure that that was all working. But they're pretty responsive, the maintainers, and can usually be bugged to where they will actually update if need be. And the other thing, this is noted on their repository as well, this thing just generates XML. It relies upon the server to validate it. So if you push invalid configurations, the server will yell. You'll get a big red bar at the top, and it'll say error, and it will tell you what the error is. And you can see all kinds of issues, like if you don't put an SSH key to hit source control, it'll say, hey, I can't clone down these repositories because I don't have an SSH key. I can't access them. Other things like that, but invalid config, usually you'll see an error thrown up there as to why that's going on. So like I said, this takes Python code and translates it to XML and then posts to the GoCD server. And it can be used to reverse engineer pre-existing pipelines. So if you don't want to deal with writing Python code right away, you can go through the GoCD UI, build out your pipeline, and then run Gomatic against it and tear it down, break it down, and it will actually spit out some Gomatic code that you can then use to continue configuring if you wish. Yeah. Oh, yeah, food if you want it. Go wild. All right, so I'll be putting the PowerPoint up probably in like the DevOps channel and maybe a couple other places. I've got the links on here for some of the things I've talked about. So the YAML config plugin, this is what will allow you to use a YAML file to actually configure a pipeline. The basic concepts in GoCD, so that goes back over kind of architecture and how the pipeline object's broken down and things like that. Hodolint, which is a tool that I'm using for my example pipeline, and it's used to lint Docker files. And then Gomatic, which is the actual Gomatic repository. And now we get into the riskiest part of this, a live demo. So I'm going to kick off the Terraform real quick. We're setting this up in AWS, and so I'm going to kick this off, and then we'll go back through, and I'll walk through how I've set this up. And ideally, I'll be able to publicize this. You guys can pull it down and play with it, and it's relatively close to a production-grade GoCD. You'll need to add plugins for authentication. But outside of that, it should have everything else ready to go. Oh, and you also have to think about how you want to persist your data if you ever have to tear the server down. We use EBS volumes, but you get back to a database, or there's various other things based on the plugins that you can do. But I'm going to kick this off, and then we'll go through the Terraform, because it's going to take a minute to run. Yeah. A little more? Okay. How's that? Okay. Yep. Okay, now let's go look at this real quick. No, wrong one. There it is. Okay. So I've got a series of modules here. Before we get into that real quick, so when this does get published, the only thing, and I'll put it in the README, that you guys will have to update is whatever profile you want to use on AWS. So this is assuming you have your AWS credentials all set up, but I'm going to leave that empty, and it's up to you guys to go pick your profile. So circling back around, we got a series of modules. I'm setting up a VPC in AWS with a public and a private subnet. The public subnet is only going to have a Bastion instance that we can do SSH tunneling through to run our configurations or to connect to the server or the agent if we need to troubleshoot them. And then load balancer to serve traffic to and from the GoCD server. Technically, though, part of that is broken. I haven't gotten it quite working, and that is the DNS routing. So when this is all set up, we'll be hitting the load balancer directly as opposed to using a legitimate CNAME DNS record. We got security groups, which I'll go ahead and get into this one. So there's a pile of them, but basically we need to have SSH into the Bastion, an outbound all for everything, an SSH in that's applied to the agent and the server. They're pretty much the same. Ideally, what you would do is you would change the CIDR blocks to actually only allow for connections from the Bastion instance. But I was kind of lazy and just left it open to the world. A GoCD server in security group. So like I said, when we were going over the necessities for a GoCD server, it needs to be able to listen on 8153 and 8154. 8153 is going to receive connections from the load balancer. That's going to be your UI and API calls. 8154 is going to receive connections from the agents. The other important distinction is 8153 is HTTP, 8154 is HTTPS. So if you ever have issues with your agent connections, you might just not be doing HTTPS. I ran into that several times last night trying to finish setting this up. It was very frustrating. Agent connections do have to be HTTPS. Question was, do they need to be? Yeah, it's required. It's for security's sake because you're transferring secrets usually over to the agents. And they're pretty prescriptive on the way that those connections need to work. I have an ELB inbound is the last thing, so I'm going to have the load balancer listening on port 80. And I'll go into how that traffic's translated from the load balancer to the server. Let's see what's up next on our modules. Server, perfect. So server is a very simple EC2 instance. The AMI ID is served up as a variable, but I just went and pulled the latest Linux 2 AMI that's on AWS. And so that's your base image that you'll be leveraging. Picked a small instance so I wouldn't have to spend hundreds of dollars running this demo. And actually, based on what I saw, I've had this running for about 8 hours, and it's cost me less than $1. So it's pretty cheap to go run this. A key name, I generate the provision key through the Terraform. So what I did was an SSH key gen, and then I dump the public key as a part of the variables here. So that's what's used to actually stand up the EC2 instances, and then you'll use that private key as a part of your SSH connection. So, and I'll show a little bit more about that with Ansible. It's a little clearer how that SSH connection is supposed to work. And then security groups, and I'm doing some module outputting so that we can pass these things around and just run a simple Terraform apply as opposed to module targeting. And then the agent, pretty much the exact same thing. I'm using a single key, SSH key for all these, so I don't recommend that. Ideally, you split up your provision keys and have them separate so that you're a little more secure. If someone gets your bastion key, they can only get to your bastion. And they can't connect all the way through to get onto your agents or your server. And then load balancer. So the load balancer is going to listen on port 80, and it's going to go ahead and transfer that traffic to 8153 over to the server. So we'll hit the UI. We'll hit the UI endpoint. And it is coupled to the server, the GoCD server. So the other thing is we have a health check on 8153. So if the GoCD server service ever breaks, stops working, whatever, the health check will fail. The load balancer will stop servicing traffic, and that's something you can go check in the AWS console and figure out, okay, instance is unhealthy, so that means the service isn't running, and get back on there and restart it, or re-instance it if you're fully automated. All right, so let's take a look at real quick if these instances are up, because they should be. Sweet. Everything's running. So next up, so I'm using a quick script here that I wrote that will build a dynamic SSH config for tunneling. So this is just a little bit of hand-wavy magic. It goes and it, using this, here I'll show you this, ec2.py, ec2 private, and EC2 public. This is actually something that's supplied by Ansible, and it's used for querying AWS EC2 to find instances with the tag name that matches, or it's really the key value pair because it's all about the tagging. So you basically provide the tag that you want to match against, and it will query that, grab the public or private IPs depending on what it needs, and serve those up to you. So it's a really handy way of, you can utilize that with some custom scripting to actually build out an SSH tunnel to execute Ansible. So we'll go ahead and apply, if I can find the command, somewhere up in here. Sweet. So before I run this, we'll go through this real quick. So like I said, EC2 anypath, so this is basically telling it, hey, go query for EC2 instances with this tag, which matches up to, I'm looking for a tag GoCD server, and I'll show this in the Ansible as well because it's explicit in the Ansible. Go against this AWS profile, some additional SSH args, and then the actual playbook we want to execute. So if we execute it, it's going to use that, and it's going to go build up and actually set up the GoCD server. And while that runs, we can go look at that. So we are running the GoCD server playbook. We got a few vars here, and then we've got 2 roles. So the roles are the actual like pieces that are executed. We'll look at common first. So, oh, there it goes. Ignore the red squiggly lines. Just doesn't like it. So there's 2 things we're doing here that are kind of handy if you're going to automate the process of standing up these servers or really make your life a lot easier. We're explicitly creating a group and a user for Go. So when you install the GoCD server or agent, it will actually create that user and group for you if it doesn't exist. What we're doing is we're setting it up so that if we were to, say, back our working directories to an EBS volume, if we re-instance and reattach that EBS volume, we don't have permissions errors if those are generated dynamically because there's no guarantee that that group ID or user ID is going to be the same. We create an SSH directory so that we have somewhere to put our source control SSH key. We copy it over, and then we also set up Git. And Git is mandatory on the server because it actually clones down the repository and passes it off to the agent. So the agent isn't responsible for cloning. It just receives that as part of the whole, here's a pipeline I need you to execute. The other thing we do is we execute this GoCD server. So install Java 1.8, set up our Yum repository so that we can pull down Go, install it, and run it. So at this point, I think, sweet, that's done. So this is the one bit that I'm less than excited about, is we're actually going to have to hit the load balancer directly. I did not go over, I have a hosted zone set up and DNS records, but it doesn't work, so I didn't review it. Once it's fixed, I'll add that to the README and explain how that works. But if we go over to load balancers here, so we've got our load balancer. We're going to hit this A record. Oh, come on. Might not be live yet. Let's look. Yeah, okay, so it's almost in service. The health check that I have set up requires for the healthy threshold to work twice. The interval is 30 seconds, so basically a health check goes out every 30 seconds. So it takes about a minute for this to become healthy once the GoCD server is live and responding. So at this point, let's see. Aha, in service. So if we come over here, voila. That is what you should see when you stand up a Go server for the first time. You don't have any pipeline definitions, you don't have any plugins. Like if you do a really basic setup, this is it. And so it immediately jumps into a walkthrough of here's how to set up a pipeline. But we're actually going to set up the agent first because that's more Ansible before we go through the Gomatic example. So I'm going to load up the agents tab. This is where your agents are going to pop up. So it's basically your available agents that can execute pipelines. If one of them is picked up in execution, it's actually going to flag that. It'll highlight yellow, which I'll show you in a bit, and say, hey, I'm working on this. Pipelines, when you execute them, will sit and wait until an agent is available. So if all your resources are in use, it'll just sit there and wait until an agent can be assigned. So you don't have to worry about like timeouts just because an agent's busy or anything like that. So if we come back here, we're going to do the agent stuff now and then go through that. Okay, so we're going to switch playbooks to the GoCD agent. Oh, actually, forgot some things before we do that. So the agent is not quite fully automated, and this is all in the README, so I'll just pull that up so we can talk through it real quick. So these things, these points, 3 and 4. So I'm not dynamically pulling the auto register key out of the cruise config. That is absolutely something you can do. Or you can push your own cruise config before you start the GoCD service so you can control for that auto register key. I'm not doing that because, again, lazy. For the sake of time, I just went ahead and made this a manual process. And then same with the server URL. So I'll walk through this Ansible real quick and then show you how this sets up. So basically, the GoCD agent playbook, again, it gets the GoCD common stuff. So what we went through before of create the Go user, get the GitHub key, etc. It technically doesn't need those things, but I just left it on because it was easier. Then it runs this GoCD agent bit. So again, install Java 1.8, download the GoCD agent and install it. And then here, I'm actually copying over an autoregister.properties file, which goes into the config for the Go agent. And I set up the agent defaults, which goes into basically nvars for the service. And to look at those, so the autoregister.properties, this is where we can add in our autoregister key and our resource. So the resource is basically that logical definition of here's what my agent is responsible for. Entirely up to you how you want to do it. We do agents for Docker builds that are separate from Java builds, et cetera. If you want to just have one agent that does everything and just have a bunch of those, you can do that too. So here I'm going to do a resource of Docker, and then I've got my auto register key, but that's not actually right because we allowed that to be generated dynamically by the server at startup time. So we need to go grab that. So what we'll do is we'll connect to the server, change to the Go user, and go to here, and there's my cruise config, so we'll take a look at that. All right, so here's my auto register key. And every time you stand up a new server, it's going to be different unless you set that explicitly by pushing a cruise config out before you start it. So we've got that. We can drop that into here. And then the last thing, hit Control-C, copy-paste, most dangerous tool out there. All right, new auto register key, and then we got Go agent defaults, so we're going to have to change this URL. And again, the agent hits the server directly, so we actually have to go pull the private IP out of the server. And since they're in the same subnet, they can see each other and talk to each other. So we'll pull that private IP and replace that here. And again, has to be HTTPS. I lost like 2 hours to this, not realizing that's what was going on. Super frustrating. And the logs do explicitly say it too. I was just really brain fried, didn't put it together. So go ahead and cancel this SSH connection. We should have everything now to get an agent going. So we're going to go ahead and build that dynamic config up again. And then execute that. So while that's running, there was one other part of the Ansible I didn't go through. So the last thing that I do with the GoCD agent is I have this Docker tools playbook. And this is for the Gomatic pipeline. But I go ahead and I install Hodolint and Docker. I make sure that Docker's running, and I go ahead and create a Docker group and add Go to it, so that way we don't have to do any sudoing during pipeline execution, because it's added to that group, along with this passwordless sudo. So give the Go user access to the Docker service, and then make sure it doesn't have to use sudo to do any sort of Docker execution. Otherwise, you get that really fancy, like, with great power comes great responsibility message that you have to approve. That's pretty default on most boxes. So it's kicking off the Go agent service, and while that runs, we should be able to see this thing come up, assuming this one works. This is the one that it fails on, if it ever fails. Fingers crossed. Sweet. All right, so now that that's running, voila, we have an agent. So it's tagged resource Docker. We got an agent name. We didn't override, so it basically just takes the host name of the box. It's got the OS, Amazon Linux 2. That's really defined by AWS, but whatever you choose to run it as, if it's Debian or whatever, it'll put that up there. An IP address. And the status, this is the important key that shows us that the auto register key worked. It's idle. So if the auto register key fails or you don't put one in, it's going to come up as pending, and you actually have to check this box and hit enable. Then it's live. It can basically go ahead and execute pipelines, all that fun stuff. So if it ever comes up pending and you're trying to do an auto register key, that means that's not working, and you need to go figure out why. Common causes of this are incorrect auto register key or trying to go through a load balancer, like I said before. So we've got an agent, we've got a server, but we need pipelines. So the last step to this is to use Gomatic. So I'm going to go ahead and pull up my Gomatic example before we execute it. So I've just got a bunch of super fancy Python code right here, right? So this is using Gomatic. Gomatic has some documentation. It's not the best, I'll be honest, but if you go through their tests and stuff, you can usually pick out exactly how this is supposed to work. And this is a decent example of most of the things you're going to need to know to start standing up pipelines. So this should be publicized as well, and you can go look at this as an okay example. So the first thing we do is we set up a configurator. And so this is basically the core piece that's responsible for taking everything that you define, translating it to XML, and dumping it up to the server into the cruise config. So we're going to have two pipelines, actually, because I wanted to show artifact transfer from pipeline to pipeline, as well as the upstream, downstream. So the first one's going to be a lint stage for a Docker file. So I go ahead and I set up a pipeline group, which will be called Docker lint. Then I go ahead and I set the material. So I use a Git URL, and I'm going to go ahead and pull from another one of my repos that has some Docker files in it. So this basically says this is the material to watch for. And you can actually whitelist specific files within a GitHub repo or Bitbucket repo, whatever, and GoCD will watch for those changes, and when a change is published to one of those files, it will automatically execute. Then we get into the actual meat and bones of configuring a pipeline. So the first thing we do is we set up a stage. So we ensure a stage here, we're calling it Docker lint. Then within that stage, we ensure a job. And again, I'm gonna go through, I know this is probably confusing, but we'll go through it in the UI and it'll be a lot clearer. We set up a job. For that job, we ensure that it's gonna use our Docker agent. So this is a really important piece because if you are gonna resource tag, you should be very clear what you expect for your resource to be for the pipeline. Otherwise, the server will hand it off to any old agent. And we've had issues where, what's that?
You can have multiple agents with that same tag and it'll just choose whichever one is readily available.
Yeah, so the question was that if you can have multiple agents with the same tag, and yes. So it's basically whoever pulls first and gets it.
Can you have multiple tags for an agent?
And the other question, can you have multiple tags for the agent? Yes, you can. But we've had issues before testing one of these plans where, like, I forgot to add an ensure resource on there, and it was a Java build, and our Docker agent was picking it up, and Docker agent doesn't have like any of the necessary tools for that, so it would just say, I can't do this. You know, service not found, or most common one was like Gradle not found. So then we actually build out the task. So this is the actual executable command that we're gonna run. I dump, as a part of the agent configuration, I just dump autolint into temp because it's easy and I know where it's going to be. So we're giving an explicit path to it, as well as the Docker file we want to execute, which I've named Docker file, very convenient. And then this is the actual part where we add the task to the job. So exec task is another piece of Gomatic, and that is what is used to add tasks for Linux or Mac OS, if you're using that as well. So we do a bin bash LC, we add the task, and then we set an explicit working dir. So what's going to happen is the server's going to clone the repo down. It's going to hand it off to the agent. Agent's going to say, sweet, got it, got my set of commands. And it's going to start with its working dir in that cloned repository, so at the root level of that cloned repository. My Docker file is 2 folders deep, so I set the working dir to be 2 folders deep so I don't have to give a super explicit path in my actual executable command. And then the last thing is ensuring artifacts. So GoCD will store artifacts from pipeline executions for you. It has artifact cleanup that you can set based on either constraints on hardware or just on a timer if you so choose. But we're basically saying we're going to have a build artifact from this, so save it off so that we can retrieve it for other pipelines, or if we want to get on the UI and download it, we can do that. Then for the second pipeline, we actually do a Docker build. So pretty much all the same detail, except we're not setting a Git URL. Instead, the material that we're ensuring for a pipeline kickoff is the previous pipeline. So the way that it'll work is you'll execute the Docker lint. When the Docker lint completes, server notifies and says, sweet, that's done. Let's kick off the next one since we have a downstream pipeline, and we'll automatically kick off the execution. Again, we ensure the resource, and the first thing we do is we go and we fetch that Docker file. So rather than clone the repository down again, I wanted to show that artifact passing. So the agent will, as its first job, hit up the server and go, I know you have an artifact, so hand it off so I can use it. And we say explicitly where we're getting it from. So we have our pipeline, Docker lint, the stage, Docker lint, and the job, Docker lint. Just went ahead and named them all the same because it was easier. And we're fetching this specific file, Docker file. So we then have a task. We add it as an exec task. Because we're pulling the Docker file down explicitly, it's going to dump to basically the root config or the root working dir. So we don't have to do that working dir change explicitly because it's just right there. And then we execute. And then this line is the last key piece. So all of this stuff as we went was actually added to the configurator as we go, because all of this is based off of that configurator ensure pipeline group. It's all connected. So what we do is we save the updated config, and that's what's responsible for actually posting to the server. So with all that, we're going to come over here, and we're just going to do Python. Oh, before I do that, I probably need to replace the URL. Again, didn't get too dynamic with this. But if you look here, we actually have the URL to the server, but I'm going through the load balancer since the server is not publicly accessible from the internet. And you don't want the HTTP. Actually confuses the request. So if we do that, no feedback, that's a good sign. So if we hit the pipelines here, we have 2 pipelines. So now we should be able to execute Docker lint. What it's going to do is it's going to go ahead and this agent's going to pull, see that Docker lint was executed, and say, I'm going to run that. So if we hit the play button here, we go here, and we can kind of watch for it. Actually, we won't watch for it. We'll go watch the agents instead. It's more exciting. So it does take a minute for the agent to pick it up, because again, it's pulling and it's pulling on a timer. And I'm not sure what the default timer is, but I'd say probably 10 to 20 seconds. Oh, nope, it's angry already. What happened here? Oh, okay, perfect. So the agent did pick it up. It was just so fast we didn't actually see it get highlighted because it failed. Happens. And this is actually an error with HotOLint. So the best part about this is if you make a change to a plan, and I'm calling this a plan here, but basically anything in Gomatic and you publish again, it's just going to overwrite it. You don't have to worry about any collisions or any weirdness with the XML. It basically just wipes out that pipeline definition and starts over. So you don't have to worry about any cleaning up or anything like that. And I did save off the fix. Like any good developer, when we get linting errors, we're just going to ignore them. So, right here. So, we will go ahead and configure one more time. Right? And now, we should be able to execute it. So we'll go into history. And then once this succeeds, so as you can see, the agent's not yet assigned here. There it goes. It's assigned. So if we go to the agents tab real quick. Really? Still not coming up? Okay, whatever. And it has passed. So it goes. Good thing we ignored all those things. And now, as you can see, because this is a downstream material and that pipeline finished, next one's kicking off. So we can look in here, and this will be a better one to actually look at the agent because this Docker build takes a minute. At some point, it will start. The yellow bar is a good sign. It means it's actually trying, as opposed to getting a red right away. Ah, there we go. So as you can see, it's actually executing our Docker build and tagging. So that's how everything works. And before I finish up, there's 2 more things I want to show you. And that is the VSM. So this was something I touched on during the PowerPoint. This is basically the big picture of how all your pipelines are configured to work with each other. So if we hit this VSM here, it shows that our source control reference originally is Git, and it actually shows the link if you click on it. Right? That feeds into our Docker lint pipeline, and then our Docker lint pipeline feeds into our Docker build pipeline. So you can see how everything builds out and connects. And as you get further in, when you have like multiple stage or multiple pipeline builds and deploys, this is a quick way to look at how everything's interconnected. When you're like 10 pipelines deep, you need something like this. And then the last thing was to go back through the whole stages, jobs, et cetera. So if we go to here, so this is our main pipeline view. As you can see, pipeline, Docker lint, stage, Docker lint. And then down here, we have our jobs. So like I said before, jobs can be run asynchronously. So you could have a whole series of these and different agents can pick them up. It's all about the resource tag. So if we go back and we look at our Gomatic configuration, right here on the ensure job, we ensure our resource. That's where the resource is decided. And those can be run asynchronously, like I said. So we do like unit tests and then code quality scans at the same time at Sonic. That's one of the things that we'll run in line. So those execute like that. And then in here, this is the actual task. So it's the executable command that runs. So it's kind of complicated, and occasionally you'll get lost but the UI provides a decent sort of like, here's each piece and what it's responsible for on the breakdown. And then we can see here on the artifacts tab too, there's our artifacts. So it actually does dump the output from the pipeline execution, the console.log from the agent, so you can go look at that, as well as a checksum if you're going to use the checksum and your actual artifacts. I think that's everything. I know this was a lot. Does anybody have any questions?
Is this the community edition or is this the enterprise edition?
Question is this the community or enterprise? This is community. And there's only a few things that are locked up behind enterprise.
And do you use enterprise at Sonic?
We do use enterprise at Sonic, and it's because they have like a Postgres backend plugin where we can keep artifact and pipeline execution stored. I think that's the one that is behind the enterprise license. So we use it for that. And then they also have things for containerizing your agents on AWS, and that uses ECS. So go for it.
Well, I was going to say, if you do the containerized agents, does that let your agents be ephemeral? Or they just spit us and spit down?
Yes. So question was, does that let your agents be ephemeral? And the answer is yes. And the server is actually responsible for communicating through the plugin to AWS to do that. So what you'd do is you'd publish an image and then set up a profile on the plugin that says, for this pipeline, we want this image, similar to the resource tagging.
Does Gomatic need an API key for the server, or is that a plugin?
Question was, does Gomatic need an API key for the server? No, it needs admin credentials if you do lock it up, or credentials for a user that has permissions to do things. So for us, we have a SAML plugin on all of our GoCD instances, but we have an admin account. And so we use admin credentials to publish that stuff.
Can you talk a little bit about how you guys manage and version your pipelines over time since you're doing pipelines as code? Like what's your process for, well, this pipeline needs to be updated? How do we ensure which version of the pipeline is the one that's associated with this?
Okay, so question was, how do we version our pipelines? And the answer is actually we just use GitHub, kind of. So what we've done is we've taken this like 4 steps further, and we have a series of plans that we leverage. And then those plans can be used by the devs. So all they need to know is a small piece of configuration to say, hey, I need a pipeline with this plan, and it will stand up a new one. And we actually have a GoCD server that's responsible for configuring all of our other GoCD servers with the proper pipelines. So when we execute an update for, let's say, our Java build, we change the plan, every single Java build pipeline gets hit at once. And we've unified too, so we've basically standardized our Java or whatever else might be used and said, this is how you're going to do it so that it works with our stuff. Anything else?
What's the Windows support on this?
Question is, what's the Windows support? And it's actually got decent Windows support. There's Go Agent for it. Most of your pain and suffering that comes from that is just because you're working with Windows. But the command shell, so basically when it executes the tasks, it'll execute through PowerShell. So you just got to make sure that everything's set up to work with PowerShell properly. But we do have a series of Windows agents, and those were the first ones we containerized because it was a little easier. We have a motto of self-service, so we've tried to put as much as we can in the hands of the devs. However, for our Windows folks, some of whom are here and can attest, we've sort of left them to their own devices. So we containerize those agents as a way to help with that. But no, it's reasonably well supported so long as you're okay with working with Windows and or forced into it.
With the exception of Elastic agents.
Well, yeah, the Elastic agents, so what I was talking about with the AWS ECS and allowing to containerize through that plugin, that is not supported yet. We asked ThoughtWorks when it would be supported, and they sort of said, we'll get to it if we ever want to get to it. So, anything else?
What have been your biggest pain points so far?
Biggest pain points? It's a toughie. I would say things like the Windows agents. We have all this automated. So, we've got, I think we're up to 7 GoCD servers split up by various responsibilities, and we can tear those down and stand them all back up in a day. So the main issues comes from more of the, like, for example, keeping Gomatic and GoCD in lockstep. When we went for a GoCD version update, it actually broke a lot of our pipeline configurations because some of the object definitions at GoCD didn't actually match the config being built by Gomatic. And Gomatic will let you publish. It'll build an XML and publish, and it's up to the server to tell you. So we did figure that out, and we got it fixed. We reached out to ThoughtWorks, and they updated the Gomatic repository. But that's one, and then agent auto register is another one. Oh, documentation for, for GoCD or for Gomatic? They have GitHub, public GitHub repositories where you can find that. And then they also have, it's a link on my PowerPoint. It's, let's see, this concepts in Go, it links you to like the entirety of it. I just focused on that one because it has the object definitions, which I went over, but it runs you through how to set up a GoCD server containerized, how to do it on a Linux box, on a Windows box, et cetera, et cetera. I mean, it does everything and gives you a quick guide into that.
So what are the pros for you all to choose GoCD over the plethora of other tools that are out there?
That's a question I'm not ready to answer. So the question was, why did we pick GoCD over everything else? I wasn't around when we picked GoCD. I'll say that we contract with ThoughtWorks, so we had some expertise available and ready to go. And we have looked at other CI/CD tools, or at least I've read about other CI/CD tools and looked at it, and none of them have anything over GoCD that I would say like that's a clear winner. Because there's so many CI/CD tools out there, you know, it's whatever fits best or whatever's already in the org.
You mentioned the secrets management a little bit. Can you elaborate on that a little? I'm not sure I got exactly how it's handling the secrets.
So I'm not handling secrets here, and I made the decision to do that because it was going to be really finicky, mainly because most of the examples I was going off of are very abstracted with the automation piece. But basically the way you would do it is Gomatic can handle secrets, and you got to look into basically how that's, again, it's all very blurry from what I was looking at. But if you're going to do secrets manually, there's an endpoint on the API that you can hit passing that secret that will encrypt and store that secret on the server. Then you can basically say, this pipeline requires this server, and it will come up. So if we look at this guy again, and we go to here, you set the secrets as environment variables. So as you can see, there's a bunch of environment variables here, and it'll set the secret as an environment variable. It will be starred out and won't be publicized because it knows it's a secret, and it sets those on the agent so the agent's ready to execute.
And you can also add those secrets in via the UI. You don't have to use the REST API.
That too.
You actually go into the settings of each stage and just set those environment variables.
To repeat that, you can go through the UI to set secrets as well.
Do you know, does it integrate with like HashiCorp Vault or anything like that?
That is an excellent question. So the question was, does it integrate with HashiCorp Vault? The reason that these guys are laughing is because that's what I've been working on for the last few weeks. They don't have any plugins. That doesn't mean they're not planning to support plugins, and they actually accept a whole lot of open source. So Sonic actually open sourced a SAML auth plugin for GoCD that you can go use. And that's something we're trying to figure out right now is what's the best way to do that.
So based on that last question, I take it that I looked at GoCD 4 years ago, and one of the biggest reasons we countered was the fact that it didn't have a lot of plugin support. There was not a lot of community around. Is that pretty much still the case today? If you want to do something and there's not a plugin for it, you're pretty much doing it yourself?
Yeah. So the question is, if there's not a plugin, are you kind of on your own? I would say yes, because ThoughtWorks has very much said, here's GoCD, we're going to give you the bare bone features, and then we want to help to grow an open source community around it. That being said, there are a fair number of plugins out there nowadays. So depending on your use case, there's actually, I would say it's kind of likely to find one. But it depends. If you have a really niche case, you might not.
And to add on that, like ThoughtWorks doesn't just leave you the rules. Like if there's a plugin that you need, you're willing to do the development work on it to help create that, they will pair and help along with that path.
I got a support contract with ThoughtWorks, so that helps.
True. Adding on what was repeated is ThoughtWorks tends to be pretty responsive and will at least maybe pair, but at the very least be responsive if you need a plugin and help guide you through that process a little bit of how to make it work.
Thanks.
No problem. Any other questions? All right, sweet.